Well, good morning, everybody. It's 10 o'clock, and let's get going on today's webinar. We're going to be doing Tecplot Chorus basic training. This isn't going to be a full training where you're going to learn absolutely everything about Chorus, but it's going to give you a pretty good overview. We have loads of resources on our website that you can look into and dig into after the webinar as well. And of course, we're always here to help. So let me get started by showing my screen, and we'll get going into the webinar. All right, so again, Tecplot Chorus basics training, and we'll explain quite a lot about the product today. Presenters, myself, Scott Fowler. I'm the Tecplot 360 product manager. I've been with Tecplot for almost 22 years now. Geez, time flies. And I'm joined with Jared McGarry, who's an account manager with Tecplot. He generally handles our academic accounts, but also handles some of the commercial accounts, and has been in our tech support group as well. So he has a nice technical background as well with Tecplot products. All right, so some of you who may be new to Tecplot as a company, or just to serve as a reminder, just a little bit of background on who we are at Tecplot. We were founded in 1981 by a couple of Boeing engineers who were writing Tecplot or CFD codes, and they needed a way to visualize the results. And they hired an engineer who's still at Tecplot today, who started writing Tecplot and has turned into the product that you know and love. We have about 47,000 customers worldwide. We're known as really the most complete desktop post-processor with XY, 2D, 3D, plotting, even polar plotting as well. And then with the addition of Chorus, which you're going to see today, and Python as our scripting layer, it really rounds out to be a tool that can save you time and can help you with advanced analysis. So what are we doing to save you time? Number one, you'll find that in post-processing, one of the slowest things about post-processing is actually getting the data off the disk. CPUs are getting faster. You're getting more and more CPU cores that you can use, but disks just aren't keeping up. So we've invented a new data file format called Sizzle. It stands for Subzone Load on Demand, which basically means that we only load the cells that you need for the visualization you're doing. So if you look at the representative image here, typical post-processors and typical file formats will require you to load the entire volume data just to produce this very thin slice. The Sizzle format will load just the subset, which means faster load times and less RAM used. Tecplot Chorus is about understanding ensembles of data. So Arrow databases, design of experiments, trade studies. Tecplot Chorus is a great tool for that, and we'll talk more about that today. And then, of course, automating your workflows. You need to get work done while you're sleeping, and the scripting languages that we supply, the Tecplot macro language as well as PyTecplot, allow you to do that. They're incredibly powerful. The Python language actually gives you direct access to the raw data in your post-processing, so you can do advanced analysis with it as well using Python toolkits such as NumPy and scikit-learn. All right, so diving into today's agenda, we're going to show you how we explore a Cart3D dataset using Tecplot Chorus. And so we're going to show you how to view images that came out of this set of runs. We're going to show you how to identify cases of interest using scatter plots and line plots. We're going to show you how to do a deep dive into the simulation data. So deep dive is a term that we use that really just means from Tecplot Chorus, we're going to launch an instance of Tecplot 360, thereby deep diving into the raw simulation data. We'll show you how to do grid comparisons. So the study that we're showing you today is constant grid run over a mock alpha sweep. So we're able to easily compare those grids in Tecplot Chorus. And then we'll show you how to create new images and how to create new variables. Oftentimes when you run an automated workflow like this, you're creating images during the simulation, but invariably you find something that you want to dive deeper into and create additional images after the fact. Tecplot Chorus can help you do that. So the data that we're going to be using today is a Cart3D delta wing model. and this was run over a mock alpha sweep. So it resulted in about 200 Tecplot PLT files as the output. So we have the solved geometry as well as cut plane output. We're going to be focusing on the geometry output in the webinar today. Created about 800 residual files, so that's your forces and moments information, etc. And then we also have about 1,400 images to look at. And this is a pretty small aero database that we looked at here, but it still produces quite a lot of data. So how do we really make sense of that? So the data and scripts are available at that link. One thing that we did notice just recently is when extracting that, you do get some errors when extracting the zip file at that location using WinZip, but the data does seem to come out just fine. So we'll get that updated soon, but you may encounter a couple of unpacking errors when you open up that script. So let's just dive right into the live training and explain the data set that we have. So I'll give you a little bit of a lay of the land here. So this Cart3D data set, you can see how the data are organized into folders. And so we have, here we have Mach 0.5, Alpha 0, Beta 0, Mach 0.5, Alpha 1, Beta 0, etc., all the way down to Mach 1.8, Alpha 10. So I think this actually totals 99 individual runs. And then within each folder, the original data had some additional folders in here that we've removed for size of the zip file, but Cart3D ends up with this folder called best, and this is the folder that that has the information that we really care about. So within each one of these folders, you have your PLT files, you have your forces and moments information, and really to explore this aero database, we need to extract information out of files so we can get a better understanding. So in order to do that, we wrote a little Python script that would crawl this directory. Let's go back up to the Delta Wing folder. And again, this script is included in that package that you can download at the Cart3D link. So if you just Google Tecplot Cart3D or Chorus Cart3D, it should get you right to that link. So this Python script we wrote will crawl through this directory and extract information out of the file path. So we get Mach 1.8, Alpha 3, Beta 0, and it will create a list of files and extract actual the integrated quantities out of some of those forces and moments data files. And we found that a lot of our customers are doing this already. So if you're doing DOEs or if you're doing aero databases, you may already have a CSV file with information in it. Chorus is designed to take a CSV file. So we're going to show next, we'll show what that CSV file looks like. So here's the resulting CSV file, and I'll just give an explanation of what we have in there. And this is the key to the input to Tecplot Chorus. So again, if you have CSV data, it should be very easy for you to adapt your CSV file to load into Chorus. So again, we have our independent parameters, alpha, beta, we have Mach over here, and these are marked as independent parameters. And then we have integrated quantities that get extracted from those forces and moments data files, and we call these dependent parameters because they're dependent on your inputs. Okay, and then here's kind of the secret sauce to Tecplot Chorus is having what we call auxiliary files, or files that are associated with each one of these runs. So let me just expand the column here a little bit so you can see better. So the header here is, we call this components.i.plt. This is the PLT file that we saw in that best folder. And each one of the columns has a relative path to that file. And you can see we have a lot of auxiliary files here. So we have images, for instance, We have some other PLT files, the cut planes. We'll have forces and moments information here as well. So all of this information is associated with each one of these runs. All right, so that's the general file format that can be served as an input to Tecplot Chorus. So now let's bring up Tecplot Chorus and show you how Tecplot Chorus consumes this data and how you can use Chorus to explore a file format like this. Because, you know, gosh, if I wanted to look at images associated with all of my Alpha 4 runs, you know, how do you effectively do that from the file system? It's really difficult. You have to navigate down to each one of these folders and you have to pull that information out and put it together. Chorus is going to do that for you through the use of that CSV file. All right, so let's bring Chorus into the mix here. Okay, so here's the first view of Tecplot Chorus. When you bring it up, it looks a little bit like Tecplot 360, right? You have file, toolbar, a couple of panels available to you, and what we call our welcome screen. And we're going to go straight to the file menu. There are a couple of ways to import data into Tecplot Chorus. The easiest one is just opening a CSV file through here. We also have a couple of different ways to create a Tecplot Chorus project if you don't have a CSV file. And that's a good example of using our Getting Started guide, which is linked to right over here, or our user's manual. We have some good examples of using what we call the file crawler to navigate a directory structure, kind of like you've seen. But we're just going to go straight to opening the CSV project. We'll open output.csv, and you'll see immediately we have this, what we call the table view, that looks an awful lot like your CSV file, but it's missing a few columns. It's missing those aux data columns. So what happened to those? Those get associated with each one of these rows, but you're not going to see it in the table view. And we'll show you how Tecplot Chorus uses those information a little bit later. So a quick rundown of the table view. You may notice we have these little arrows or caret type items. These are going to show you where this value exists in the full range of values. So you can see here on CD, or coefficient of drag, this first run, or this first item, is very low in the full range of the drag values, where this one is quite high in the total range of drag values. So very quickly you can get an indication of where each of these values lives in that range. We also have filters available. So if I wanted to filter down to, say, just runs that have low drag, I can do so, and you can see that we get some interesting coloring in here. So this colored shading is going to show you where that filter resides in this range, and you can see that values turn red, which violate that filter. So again, you can quickly go through and see which of your runs are violating some constraint that you want to put on your system. Over on the right side on this properties panel, you can use filters. So this is actually going to remove those cases that were violating the constraints. So if I, let's go down to just a couple of alphas and just a couple of mocks, you can see I now have a very short list. So I can very quickly filter down my metadata to cases that are particularly interesting. Let's reset all the filters here as well. You'll notice that a few of these I have just single values, and these just kind of clutter up my view right now. So some capabilities here, we'll click on the gear icon and we'll turn off or remove filters that are single value. There we are. So we've cleaned up the panel on the left there a little bit. And another nice capability here is we have a number of different filter types that you can use. So for instance, on alpha, if I want to, what I've done here is I've right-clicked, and if I choose single value filter, you can see I have a single slider, and that's going to take me through my range of values, a checkbox filter, and a list box filter. So the list box filter is quite nice for multi-select if you want to compare just a few. And these filters will affect all of the views that we show you. So let's take a look at another type of view that we have so we can really get an understanding of what's going on with this arrow database. So let's look at 2D scatter view. This one, let's look at mock versus drag. And we have a couple of other options here. You can affect axis spacing, change the coloring of your symbols. So let's do coloring by our other independent variable of alpha. And what we can immediately see here is that we get a spike in drag as we cross over Mach 1. So we can see, okay, things are pretty nominal here. We're probably getting some shock, which is causing the drag, and then the drag starts to taper off. So immediately you can see that we have a pretty well-performing vehicle here. So nothing to be worried about, but we have seen many arrow databases where you have an outlier. And Tecplot Chorus is a great way to get this nice overview and find those outliers and dive into then the simulation and what is causing those outliers. So 2D scatter views are pretty self-explanatory. Let's look at the next type of view. We have line plots as well. In this one, I'm going to do CD versus CL. And so this may look a little bit interesting. So again, Tecplot Chorus doesn't necessarily know how you want to break down your lines. So we're just looking at all 99 runs here and linking them together in a single line. So let's add a little bit more information to split up these lines in a more appropriate manner. So we'll say color by Mach, and you can see that when I do the coloring by Mach, it's now split each one of these lines into a constant Mach value. So this plot is going to look a little bit nicer, a little bit more like what you may expect it to look like. And again, we can use the filters. So if I want to focus on just a single value of Mach and scroll through there, I can look at each one of those lines individually. Or let's say I wanted to look at Mach 0.95 and 1.05 simultaneously. Very easy to get an overview of what those data look like. Again, we have some other options here. So we've done size by or color by variable. You can do symbol shapes. And symbols by a variable. We also have the ability to do some surrogate modeling. I'm not going to go into the details of surrogate modeling today. We do have some videos on this on our website. We also have information about that in our user's manual. So if looking at surrogate models is important to you, I encourage you to take a look at that information. All right, let's take a look at another plot type, the 3D scatter plots. Again, this is pretty similar to the 2D, but now we have our third dimension here. So let's look at a similar type of plot to our 2D scatter. Here again, we're looking at Mach versus CD, but we also have the alpha dimension as well. You can see a pretty similar shape there. Again, surrogate models are available in this view. One of the really nice things about Tecplot Chorus now is our selection mechanism. Let's say you find an interesting case in this view, maybe an outlier, maybe just a couple that you want to look at. You select them, and that selection occurs in all the views. It can be a little bit hard to see in some of these views, but you can see that we have a couple items selected here, a couple selected here, and then of course the ones we selected here. And the table view, we're going to have to scroll down to find those selections, and it's not very convenient to have to scroll through this list every time. So we have another view that you can use called the selected cases view. So that's available through the view menu. Hit selected cases, and this shows yet another table view as a panel down here at the bottom, and this is going to show just the cases that I've selected. So really nice way to zero in on cases of interest or items of interest that you may want to see. Okay, well, where do these fit in my design space when you're looking at the different views? So that selection model is quite nice. All right, so let's go back and let's look at just a couple of these cases at the high Mach, high alpha regime. And let's say we really want to understand what's going on with these solutions. So I've selected them. I can then right-click, and I have a number of options here. And this is where those aux files come in. When we looked at that CSV file, we had the PLT files, the image files, etc. And those are all available when I right-click. So we have a number of options here. View images. This is going to allow us to view the images associated with just these three selected runs. View data. This is going to launch Tecplot 360 and load the data that we select into Tecplot so we can compare them. Create images. We'll demonstrate this later, but this is going to allow you to create new images by running a Tecplot 360 macro or using a style sheet to define what that image should look like. Create data will create a Tecplot LPK file. So this could be useful if you want to, say, reduce your data. Say you have a volume data set, you want to reduce, do a slice and save just that slice. You could create data that way and extract variables. Again, we have a really good example of how this is used in our Getting Started guide with the SO2 plume migration study. So I would encourage you to take a look at the Getting Started guide. Today, I'm really just going to demonstrate these two items, the view data and create images. All right, so let's go ahead and just do a view data. So this is going to pop up a dialog that says, well, what data do I want to use? And if you remember from the CSV file, let me bring that up just to serve as a reminder. This first row, we have components i.plt, and we have cutplanes.plt, entire.dat. So these are my data files. So any file here listed is, or any file recognized by Tecplot Chorus as a data file is going to be listed here. You see that the Tecplot 360 loader is the only loader that was associated with this PLT file. So if you have Fluent data, if you have CGNS data, Tecplot Chorus will recognize those file extensions and choose the appropriate loader when opening up Tecplot 360. Okay, so I also have a couple of style sheets that I've already associated with this project, but let's start with no style, and we're just going to load the raw data. So now what this is doing is this is telling Tecplot 360 to launch, and it's going to load these the data from these three cases, each into a separate Tecplot frame. So it takes just a little while for Tecplot to launch and get that data loaded. And one thing I should point out here is this instance of Tecplot 360 that's launching, this is not consuming an additional Tecplot license. You're already consuming a Tecplot Chorus license just by running Chorus. So this is allowing Tecplot 360 to run without consuming an additional license. So a nice value add for those of you who are paying for your Tech Plus support subscription. All right, so this has loaded all three data sets. You can see that it loaded it in a 2D plot type. Let's switch over to 3D in this frame, and then we'll adjust some of the style. And let's get coefficient of pressure. You know, a nice way to look at coefficient of pressure. I happen to know that this one has values closer to 0.6. We'll go minus 0.6 to 0.6, number of levels at 11. This will put 0 right at the middle of my color band, and then I can use a diverging color map. This will put white right at the middle, so we can see where we have easily see where we have the positive and negative values. And then I'll just rotate around Z, rotate around X, and we'll reposition this guy and zoom in. You'll see that we have coloring only on 1/2. This simulation was done only on half of the geometry. So the other is just there for reference. All right, so let's say we like this view. Now I can just hit this button over here. When you launch Tecplot 360 from Tecplot Chorus, you get this additional sidebar. We'll just say synchronize styles. This is going to copy the style from this frame because this is the current one, and it's going to apply it to the others. We'll just take a little while to do this because, again, Tecplot 360 uses load on demand to load the data. So it had to go through a little extra effort to load CP and do all the rendering. All right, now this is great. We don't exactly know which frame is associated with which alpha and Mach, so we can easily select alpha and Mach here. Now you get a indication on your plot of which Mach and alpha inputs were used. We also have some of our outputs, so let's look at drag as well. So nice indicators right on the plot. Okay, so let's say I really like this view and I want to look at other cases with this same view, or I want to create images across my entire Aero database with this view. Tecplot Chorus offers this save style template. So really all this is doing is saving a Tecplot style sheet, and it's saving it in a very specific location such that Tecplot Chorus can then find it when it's saved. So you see that my root project here, Delta Wing, that's my root folder. Tecplot Chorus is going to create a new folder in there called Chorus Derived, and then underneath that we have this folder called Style Templates. So I'll just save this as new view.sty. And that style sheet is getting saved. Let's go back into Tecplot Chorus and let's select a different run here. So we'll go over to my 2D scatter plot, change the mouse type, and let's just look at this one right here. And again, I can right click, view data, and you can see that new view is now available here, and we'll hit OK. And over in Tecplot 360, you can see that we have a new page, case number 9, and that created a new view. Now, it went over here on the left because when I saved this one, we'll go back to this page. It takes just a little while to switch pages here. This frame is kind of over on the left side, so it maintained that frame position. So I'll just do hold down Control Shift A, and that's going to fit the frame to my view. So you can see I've applied that style sheet with very little effort by using Tecplot Chorus. Okay, let's go back to this 3-frame layout. Let's say I want to now compare, do a quantitative difference between each of these items. You can see a little bit of a visual difference, but I want to actually quantify it. I'm just going to toggle Show Diff Data. What this is going to do is it's going to use this frame as the master frame, because that's the current one, and it's going to do a delta from the CP value of this frame with the CP values of these. Tecplot Chorus looks at the contouring variable that you're using, and we'll do the delta there. Now again, we're using the same color map, the diverging color map, but it looks like we need to get the values centered around 0. So let's just go minus 0.4 to 0.4, and again 11. Wait for that to re-render, and again I'll hit synchronize styles. And this is going to synchronize just these bottom 2 frames. Tecplot Chorus recognizes these as the current frame as one of the diff frames, and it's going to synchronize the style just between these 2. There you go. So now you can see a quantitative delta between these plots. So Really nice capability to do very quick diffs between your raw data. Okay, so that pretty well covers it for the capabilities that are available within Tecplot 360 when you're using Chorus. All the other regular Tecplot 360 capabilities are there, so you can do slices, isosurfaces, etc. But Chorus, because it's designed to look at ensembles of data or groups of similar data, we have these additional capabilities: the synchronized style, the save style template, show diff data. Okay, so back into Tecplot Chorus, let's say again that view of my data, I want to create additional images, and how can I even use images within Tecplot Chorus? So let's look at another one of the views that we have here. It's called the matrix view, and I've pre-computed a number of images as part of this simulation. So you can see I extracted a slice and I created some CP curves. I zeroed in on the nacelle, again looking at CP, looking at kind of that top view that we had already looked at. And let's say that that view that I had, which was a little bit further zoomed in on the wing, I really want that as part of my set of images. Well, again, I can do that quite easily using Tecplot Chorus and that Create Images option. So let's do this just for the first 10 images or 10 runs. So we'll say Create Images, and we're going to choose that same data. New view.sty. We're going to define a width for the images. Now, just a note, Tecplot Chorus in that matrix view, we max out at 800 pixels. So anything beyond 800 pixels isn't going to be necessary for viewing within Chorus, but if you want to view that image outside of Chorus, it's nice to do a slightly larger image size. And then we're going to give also a tag name so we can uniquely identify this set of images. All right, so we'll just hit OK. And what this is now doing is it's launching Tecplot 360 in batch mode in the background, loading the data, applying that style sheet, and creating an image. And it's important to know, where is it creating the image? Well, it's creating that image in each one of these folders. So we go down into best, we'll see Chorus derived, and we should see a new folder, or sorry, a new image being created in here. So here's new view.png. So you can see that we have a new image available there. Right. Again, this doesn't consume an additional license of Tecplot 360. So if you have colleagues who are using a GUI license or using Tecplot 360, again, this is relying off your Tecplot Chorus license being checked out. Again, when you buy Tecplot 360 and are paying for active maintenance, Tech Plus maintenance, you get a license to Tecplot 360, a license to Tecplot Chorus, and a license to PyTecplot or Python API. So this is just going to take a few more minutes to run, and we should see the light turn green down here in a little bit. So while that's going, let's take another look at the matrix view and show you some of the capabilities in here. So the matrix view is a great way to look at all the images across your simulation run. So we have a zoom capability here, so we can zoom in and out on our images. You can see that I have some items selected. That's why these are showing up as selected as well. And again, we use this term tags. So the tag is just, again, a way of uniquely identifying a set of images that may be at different file locations. So click on each one of these, and you can see that I can see effectively the full database here. Now, it takes a little while when I first click on these, because we have 100 images that are all 1024 pixels, so we have to load those off disk. We're loading those into memory. So when I go back to these tags again, it's going to be quite a lot faster, so we don't have to re-access these data on disk. Okay. Now let's say I want to look at multiple items at once. Let's do columns by tag, and then we'll just select a few items here. And you can see I have this little icon here. This indicates that I have multiple images at this location of the matrix. So again, this is a mock alpha sweep, but I'm only differentiating by mock here. So if I say page by alpha, you can see that icon went away, so I'm showing a unique image. So all of these are showing at alpha 0, and then as I slide through, I can very quickly look at all of the images that I've captured for Mach 0.5, alpha 0. I want to look at just, again, a couple of runs together. So again, 0.95, 1.5, let's say I want to throw in 1.8 there as well. Zoom out just a little bit. And then I can very easily sweep through all of my images and see the CP curves, the integrated outputs, and the views of my geometry. All right, so that's the image view. We can also show labels on each one of these. So let's say I want to see what my drag is for each one of these as well. Those show up as additional labels available. All right, so you can see that job that I ran of the additional images is now done. Again, we only did this for the first 10 in the simulation. So let's click Manage Jobs. This tells me that I did a create image job. Let's widen this a little bit. We used the new view.style and gave it a tag. So we'll just hit deposit and click through. And you can see that now I have a new tag available here. New view. Of course, nothing's available for this set of constraints. So let's again reset all the filters, and you can see that we have a new view available for this mock, and we can go through our alpha, or let's go back to these settings, and so we can see all of these simultaneously. Okay, so that's a quick run through of Tecplot Chorus. There are some other capabilities that I didn't go over today that are useful, and let me just touch on them a little bit, and we'll give you an idea of what you might want to look at in our Getting Started guide or in the user's manual as you're exploring Tecplot Chorus. The View Images option, so this is going to pop up a view that just shows you all of the images for a specific selected case. So in this case, I've selected just Mach 0.5 alpha 0. So this is just going to show me all of the images available there. Selected image view can be kind of handy if you really want to just zero in on the images for one case. I didn't go over the surrogate models. Again, take a look at those. Ask questions of our tech support staff if you need help with those. The file crawler, again, if I go back to our layout here, Delta Wing, and then all these folders, the file crawler can be useful to get initially your data in, but it doesn't have the ability to actually parse information out of other files that are in there. So it simply looks at the file path and tries to extract useful information out of the file path. So for most users, the CSV file is much more useful than the file crawler. Another really interesting capability is what we call custom actions. So you'll see a couple of items in here between these separators, capture instructions, open VTU files in same frame. These are custom actions that I've created. So Tecplot Chorus does have the ability for you to register a script or an executable that can perform an operation much like these other operations, view data, create images, etc. So we've had users that have connected CAD data with Tecplot Chorus, and so they've registered a custom action that will allow them to select the tag that's associated with their CAD files and launch a CAD application. So this is done, the way this works under the hood is Tecplot Chorus will create an XML file, which then your script has to parse to understand which data files have been selected in the Chorus UI, and then you can do effectively whatever you want. So there are some examples of using that, and if that's something that sounds interesting to you, I would contact our support, because it can be a little bit tricky to get working, but we do allow for that plugin capability. All right, so that does it for the Chorus demonstration today. So thank you all for your attention. Let's round out the webinar. We'll jump back into the PowerPoint, and then we'll open it up for questions and answers as well. So just a quick recap here. What are the main benefits of Tecplot Chorus? It's a great way to organize tens, hundreds, or even thousands of results. We did a webinar quite a while ago with Swift Engineering. They had only 13 simulation runs where they were looking at the aerodynamics of a rear wing on a Formula One car or an Indy car, and they found that Chorus was quite useful for only 13 cases. So it can be a great way to organize your work and a great way to look at images and outputs from multiple common simulations at once. It helps automate the creation of new images, and of course, anytime you're paying for Tech Plus, you get access to Chorus, which also means you get access to our tech support staff. And we're really happy to help you out. All right, so again, feel free to use that question and answer pane to ask some questions about Tecplot Chorus or even just Tecplot 360. Just a quick reminder here, our support staff, support@tecplot.com, they're gonna be your fastest way to get an answer to your question. If you're paying for support, you have the ability to contact us. And our turnaround time is really fast, usually in under 24 hours. If you're in Western Europe, use support-eu@tecplot.com. Our staff over there also very responsive. And then if you're outside of the US or North America or Western Europe, visit our website and find your local distributor. They're gonna, again, give you the quickest response time because they're in your time zone. Right, and prior to the webinar, we had some questions that came in earlier. And these are pretty Tecplot 360 focused, so I'll try to go over these. How do you easily visualize cell sizes of the grid as a density plot? So I'm not 100% sure if I'm going to answer the question here, but I'll give a demo of how I interpret the question. So we'll just use this data set again. So if we go into Tecplot 360, we go to the Analyze menu, Calculate Variables. We have an option in here to calculate the cell volume. So the cell volume is a little bit overloaded term because it's actually going to also compute cell area for your 2D cells. And this data set is finite element triangle, so we're going to be computing the cell areas. Now, because it's a cell-based value, we want to choose cell center, and we'll go ahead and hit calculate. That takes just a minute. And let's go into contour and multicoloring. I like just double clicking on the legend to bring up the dialog, and we can select cell volume. So now this has now calculated the cell volumes, or cell areas rather, and you can see that we have just a few values here. We'll click on the add contour level to add a little bit more detail here. So now we can see a contour plot of what my cell sizes or cell areas are. Now, if you actually do need cell volume, you might be able to use an isosurface to find areas of high cell volume or value blanking, because then you're going through a three-dimensional object. You could also use a slice and pass it through there, because that will adopt the cell volume of the source cell. So hopefully that answered the question. Another question that came in, is there a way to change the default fonts and sizes, or at least is there a way to change for the entire frame and not for each axis separately? So this is another good question. And let me just show an example of this. We'll go back to a 2D plot, because axes are available by default here. So one thing that you can do is you can use frame linking. I go to the within frame and say axis style. Now, if I double click on the X axis here, and let's say change the color to red, you can see that this is going to change X and Y simultaneously. Same thing with the labels. We'll change these to green. You can see that this has changed X and Y simultaneously. So that can help out with axes. If you want to change the defaults completely, you can do that in the Tecplot configuration file. We'll just show you where that lives. So we have a tecplot.cfg file, and this can take tecplot macro commands to define those font defaults. So you would just add a command in here. So here's an example of changing line thicknesses. So our line thickness menu, I think, defaults to 0.5, 1, 1.5, 3, and 4. So you can change some of those GUI defaults, as well as other options here. Now, one thing to note is the tecplot.cfg file. If you're on, say, a Linux machine and it's a shared installation, changing this tecplot.cfg file in the Tecplot directory is going to change it for all users. So maybe your company has a set of defaults that they want everyone to use. That's a great place to make the change. But if you want to change it just for yourself, you can have a tecplot.cfg file in your home directory on Linux. In that case, you're going to want to add dot. So it's .tecplot.cfg, and we'll pick that up and use that as the defaults. So, Jared, were there any other questions that came in during the webinar that we should answer today?
Yeah, there were a lot of good questions that came in, and one of the first ones that did was about how to get Tecplot Chorus, because when you look to download from our website, you can see Tecplot 360 and our other software, but there's no Tecplot Chorus. And this is because Tecplot Chorus is included in the installation of Tecplot 360 for Windows and Linux operating systems. And then one of the follow-up questions to this was if we have any plans to support Tecplot Chorus on Mac OS in the future.
Yeah, so Tecplot Chorus on Mac is kind of a sticky subject for us. We're using a GUI toolkit called Qt or Qt, and we've encountered bugs with that GUI toolkit on the Mac, and just have not felt that it produces a good enough user experience. So until the Qt GUI toolkit can resolve some of those issues, there are no plans to support the Mac. I know that the Qt is currently on planning to release Qt version 6. So each release, we take a look at it and we hope that the issues get resolved, and we haven't seen them get resolved yet. So we're waiting on some fixes there from the base toolkit.
Great. All right, another question that came in was more about the nature and the best use of Tecplot Chorus, asking about if it is a tool to analyze or portray an ensemble of data only, which can somewhat be done with Tecplot 360 via the append function or via the usage of multiple zones, but it requires a lot more clicks than Tecplot Chorus would. But it's asking if there are any other functions to Chorus. And you addressed this to some degree, Scott, during some of the other tools like the deep dive into Tecplot 360 and the image generation. And in addition to this, there's some surrogate modeling tools in Tecplot Chorus. So it's not just a organization and management tool of Tecplot 360 data, although it is really good at that. It has a couple other applications. Is there anything else you wanted to add to that, Scott?
No, I think that's a fair response. And to the user who asked the question, if you need any additional detail, please do feel free to ask us after the webinar, of course.
Yes. Another question asking about, in addition to the line plots of forces and moments shown earlier, is it possible to load point CP data? I assume this would have to be loaded in a separate DAT file.
So I think what this is asking, like, for instance, so here I have these plots that the way that I produced these is, let me just go to create images. In this case, I ran a macro to create a CP curve. So what this did is it would load the PLT file, and then in Tecplot 360, after loading that data, I recorded a macro that would create a slice, extract that slice, and then plot X versus CP. You could, well, you should be able to. I haven't tested this, so you should be able to do a create data command where you select this and have a macro that creates that CP curve and then writes out only the data that you care about. So you may be able to do that. And if for some reason that doesn't work, you could always use a custom action to get really fancy and create the data that you need. In that case, you would then have a new data file object that you could reference in the list. So a little bit of a long-winded answer, but I think the answer is yes, it should be possible, and yeah, it should be able to be done.
All right, and the last question that came in is, can you create images that require the loading of two files or multiple files? For example, if I wanted an image of the surface contours PLT file with a slice overlaid using a additional PLT file.
Yeah, so this is kind of a tough one with Tecplot Chorus because if we go back to this CSV file, you see that each tag references a single data file. Now it's been a while since I've used Tecplot Chorus in this modality, but there is a way. I mean, we've tested this with, say, Fluent case and data files, where if I had two columns that have the same tag name, then those files would be loaded simultaneously. So in theory, again, I'd have to test this again. If I had another column that said components I.plt and then had this guy with, and I can't remember the actual file name, but if I just said slices.plt or cutplanes.plt, in theory, this would come in represented as a single tag, but Tecplot Chorus would then know to load both of these files simultaneously. So a little bit of upfront work. So yeah, we should definitely test that out, but Chorus has been designed to work like that.
All right, And another question just came in following up on this. Is there a limit to the number of aux files for each solution?
So I'm assuming this means that, is there a limit for the number of columns for each row that I could have with aux files? In theory, no. You may run into, at a certain point, performance issues, usability issues with having, very long lists here. But there's no hard limit included. One thing that you will notice, though, is if I, select a bunch of cases here and say view data and hit OK, we give you a little warning here saying, well, you're about to load more than 5 data files, because really, Tecplot 360 could get overwhelmed if you have large data. If you have, because of the way that we tile the frames across, it can get a little bit difficult to from the user experience, actually see what's going on if you've selected, a bunch of data. So we put some training wheels on there for you.
All right, and another one just came in. I'm assuming deltas need to be on the same grid, just like normal Tecplot 360, right?
Yeah, that's exactly right. So all of these cases have the same grid. Now, the XYZ locations don't have to be in the same locations, though. So what Tecplot Chorus does is it will simply look at how many points do I have in each one of the zones. So I have, 739,000, 739,000, and it's just going to do a straight up subtraction of the CP variable here, because that's what's assigned as my contour variable. So if this happened to have 739,168 points, Tecplot 360 here, or actually Tecplot Chorus wouldn't even give you the option here. This toggle would be gray because we recognize that the grids are of different dimensions. Okay, well, thank you everybody for your attention today. Like Jared said, contact support directly, support@tecplot.com, and we'll be happy to answer any additional questions. Thanks for your attention. Bye-bye.